All right, today you're going to be finding the area of regular polygons. Finding the area of regular polygons. And if you remember a regular polygons have congruent sides Let's just reword that. Let's say that a regular polygon has all sides congruent. Meaning, if it's a regular pentagon, all right, penta's 5. So in a regular pentagon, all the sides are the same. Okay? All of these interior angles are the same as well. A regular hexagon, all the sides are the same, all the interior angles are the same. All right, we've covered that this year. So, this next paragraph, which is on 689, just below the check it out in the middle of the page, you need to have all of this in your notes. And it says that the center of a regular polygon is equidistant, or equal distance, from the vertices. The apothem is the distance from the center to a side. A central angle of a regular polygon has its vertex at the center. And each angle measure, let's say each central angle measure, is 360 divided by n, where n is the number of sides. Now there's a bunch of information there, but hopefully when I just draw a picture and describe some of the terms to you, all of that wording will make some sense. All right, does everybody have that written down? Okay, so look. Let's write this down. Get this down next. This is real important. All right, and then I'll try it, or I will explain it. The area of a regular polygon. With apothem lowercase a and perimeter uppercase P is the area is equal to 0.5 times the apothem times the perimeter. Out of everything you just wrote down, this is the most important. So if you're highlighting stuff, I would highlight that. And then I would highlight this right here. Central angle measure is equal to 360 divided by n, and that the apothem is the distance from the center to a side. Those are the three biggies. Okay? So now these regular shapes are hard to draw, so we're going to look at that. 1, 2, 3, 4. 1, 2, 3, 4. That's just a 5-sided shape there on the top, or in the middle of page 689. So 5 is, we just said, is what? 2, 3, 4, 5. All right. Regular pentagon. All the sides are the same. Center. It's got a center. Now, when you're finding the area of a regular pentagon, you need the perimeter, right? You guys remember that the perimeter is the sum of the sides. If you know one side length, you can multiply it by the number of sides, and that'll give you the perimeter, right? Okay? And then this right here, from the center of the circle, or of the polygon, to a side of the polygon, intersecting at 90 degrees, that is the apothem. Okay? Now, talking about central angles. If you connect vertices to the center of this polygon, you see how we just created 5 triangles. Okay? When you're dealing with regular polygons, or dealing with polygons, but especially in this case, the number of sides in the shape is how many regular triangles you can form within that shape. Okay? And you form those by connecting vertices to the center. Now, this angle measure, these central angles, this right here, this is a central angle. All right, this angle right here. How many of those angles are there? There's 5 of them, right? So look, your notes said that the central angle is equal to 360 divided by n, which is the number of sides. So if you take 360 and divide it by 5, it gives you the measure of each of these central angles. And what is 360 divided by 5? 72. All right, so each of these central angles is 72 degrees. Agreed? Is everybody with me? Is anybody lost or going too fast? We've talked about a regular polygon. In this case, this regular polygon has 5 sides. So since it has 5 sides, we can divide it up into 5 equal triangles. We can find the central angle of all of these triangles by taking 360 and dividing it by the number of sides in the entire shape. So now this central angle, or all of these central angles, are 72 degrees. Here's where it gets more useful. When you take this apothem, that is the distance from the center to the side of a triangle at 90 degrees, it's an angle bisector up here. Okay? So what is this angle, this little angle in this little triangle inside of the polygon? 72 divided by 2. So this angle right here is 36 degrees. And that's where all of this is going to hopefully start to make a little bit more sense. And since this was an angle bisector, this apothem was an angle bisector of a regular polygon, aren't these two pieces going to be congruent to each other? All right, so do you see what the apothem does? It gives you it gives you the distance from the center of the polygon to the side of a polygon. It bisects the side of the polygon, and it bisects the central angle. So there's a ton of stuff going on with the apothem. Okay? Make sense so far?
Yeah.
All right. So the next thing you're gonna have to do is you're gonna have to find the area of a shape. So let's say right now, let's just say that you were given this picture. All right? And you were told that this was, let's make it 8. All right? And you were asked to find the area. So let's say find the area. So given this shape and asked to find the area, remember that the area is equal to 0.5 times the apothem times the perimeter, right? So look, the area of this shape is going to be equal to 0.5 times, don't know the apothem yet, right? What is the perimeter? Perimeter is 8 times 5, which is 40. So you're only missing one thing. Unfortunately, it's the apothem. So look what you've got based on this picture. The central angle was equal to 360 divided by 5, which was 72 degrees. So you already know that this angle is 72 degrees. And if the apothem is an angle bisector, then this is 36 degrees, right? Mm-hmm. Now, if the apothem is also, if it also bisects a side, what is this piece right here of this small triangle inside? That's 4. And doesn't the red segment represent the apothem. So do you see where you're at? You need the apothem, right? You've got one angle and one side of a right triangle. So, katoa, all right? So you're dealing with opposite and opposite and adjacent. The blue lines would all be the hypotenuse, wouldn't they? So what deals with opposite and adjacent? Toa. So wouldn't tan of 36 be equal to opposite over adjacent? So you could multiply each side by lowercase a and then divide both by tan 36, right? And tan 36. So if you take 4 and divide it by tan 36, is it 4 divided by 36? Tan equals, my calculator didn't like that. 4 divided by 36 tan equals 5.5. Yeah. So the apothem of this, the apothem in this polygon is 5.5. So now that value gets substituted here, 5.5. So the area of this regular pentagon is 0.5 times 5.5 times 40. 110. Make any sense? You think you could repeat the process?
Yeah.
All by yourselves?
Yeah.
Okay, what about this? What about, here's what you're, let's say we're given 1, 2, 3, 4, 5, 6. Okay, that's a regular polygon, I swear it is. Now, you're given this. Only. And it is 12. You're asked to find the area. So your area equals 0.5 times the apothem times the perimeter.
That's the vertice, right?
That 12 that's given is that the apothem?
Yeah. So, I mean, no, because it's not too late.
It's just the hypotenuse to a triangle, isn't it?
Yeah.
Here's what you have to do in this case. The first thing I would do would be to make this triangle right here, or a triangle. And then take 360, and what are you going to divide it by in this case? 6, because there's 6 sides. So what's 360 divided by 6? 60. So what's this angle? That angle's 60, right? All the central angles are 60. So then, if you pencil in your apothem, what is exactly? What does this angle measure up here? This is 30, isn't it? What kind of a triangle is this then? It's a 30, 60, 90. Don't 30, 60, 90s have special rules? What's the relationship between the hypotenuse and the short side of a 30, 60, 90? It's half. So what is 12 divided by 2? 6. So if this piece is 6, what's the entire side? 12. So what's the perimeter? The perimeter is going to be 72, which is 12 times 6. What's the relationship between the short side and the long side of a 30, 60, 90?
Whatever the 3 is.
times the square root of 3. So this apothem would be 6 radical 3, wouldn't it? So what's going to happen is you're going to sometimes, or hopefully it won't happen, you're going to be given a picture, and you're going to, if you look at it and you just keep staring at it, you're going to think, I'm not given enough information here. But once you start drawing or working with the figure, you're going to see that you've got all the information you need. So the area here is going to be 0.5 times the apothem, which is 6 radical 3, times the perimeter, which is 6 times 12 is 72. So look, this radical 3 is in simplest form. So if you take 0.5 times 6, you get 3 times 72. Okay, so the area is equal to 216 times the square root of 3. All right, so that's it in radical form. And then you've got I've got the 216 on my calculator. You could push times 3, square root button, and equals. And 374.12. All right, so there's your area in simplest radical form, and your area rounded to the nearest tenth. Hundredth. Thanks. Clear? All right. Your assignment for today is on page 691. Six through 9. Page 691, problems 6 through 9.
That's it?
Yeah.